So we are looking at chapter 7 review here. We're going to start with number 7. So we're trying to evaluate the expression without using a calculator. I'm not going to ask you guys to do something like this on a test, but it is kind of a nice skill to be able to use. So when we're looking at these, the biggest thing that I want you to take away is like, okay, at a high level, I know how to do problems like this. And if I were to set it up with a calculator, I know like how I would proceed. What it's looking for you to do is identify numbers like 3, 9, 27, 81. All of those are 3 to some power, and same thing with 2, 4, 8, yada, yada. So with that being said, let's look at number 7 here. So number 7 says, find the real nth root of a if n is 5. So I want the 5th root of a where my a value is -1. So what I'm doing here is I'm taking an odd root. I can take odd roots of negative numbers. So what times what times what times what times what will give me -1? Well, it's just going to be -1. Not that much else to this one. Any questions here? Perfect. So anytime I've got an odd root like that, if it's negative, it's just going to kind of keep bouncing back to that thing because it'll cancel off every 2. So if I have 3, 5, 7, 9, whatever, it'll just spit out another negative for me. Here we want to simplify the expression. Oh, let's see. 15, 21, 23, and 25. Cool. All right. So in 15 here, we want to simplify the expression, assume all variables are positive. So when we look at this thing, I have a level 6 force field. So the only thing strong enough to break out of a level 6 force field is something with a level 6 exponent. 6, I'm just going to explicitly write this, is raised to the 1st. I have x raised to the 6th, and I have y to the 7th. I'm going to write the y to the 7th as y to the 6th times y to the 1st. And again, typically I don't write to the 1st, but just want to be explicitly clear here. And then I also have z to the 10, so I'm going to say z to the 6th times z to the 4. So when I'm looking at this problem, let me throw my multiplication signs in between here just to help differentiate a bit. So when I'm looking at this problem, the only thing that can come out of this 6th root is something to the 6th degree, aka this one, and this one. So those are all going to come on the outside of this problem here. And so what it's going to look like is it's going to be x times y times z, and now, well, it's quite the z there. So x, y, z, and then I've got my 6th root of, and then what's trapped inside? Well, the 6 to the 1st was not able to come out, so it's just going to be 6. I had the x to the 6, which came out. Now it's just going to be 1 inside there, which just pretty much disappears because 1 times anything is itself. I have y to the 6 times y to the 1st, but the y to the 6 came out, so I've just got the y to the 1st, so that's going to be y. And I had z to the 10, which was z6, z4, and it's just going to be left with z4. From here, I'm good to go. Any questions on that one? Perfect. Next, we're looking at number 21. So here we're going to perform the indicator operation. We're doing f of g of x. That's how we read this thing off. So basically what I'm going to do is I'm going to put my g of x function into the x's, whoops, for my f of x function. So here's my f of x function in green here. So again, I'm doing the green thing, or excuse me, I'm doing the red thing into the green thing. So now when I write this out, I'm going to say f of, and now instead of writing g of x, I'm going to write x minus 2. And what does that give me? Well, it gives me 2 times whatever that thing is, minus 4. And again, that thing that I'm plugging in now is my x minus 2. The double parentheses here is overkill. I'm just trying to highlight it with both colors here. So I threw the g of x thing into the green f of x thing. And now I'm going to do my distribution here. So I get 2x minus 4. And I've still got this negative 4 on the outside. So this will all end up giving me 2x minus 8. Any questions on this one? Perfect. Looking at 23 first, here I want to find the inverse function. So if I'm looking for an inverse function, and when it says when it says x is greater than or equal to 0, it's basically just saying, okay, this thing did look like a upside down parabola, but we're only using the right half of it for all my x's greater than 0, so I can actually find an inverse. If I didn't have this domain restriction here, I wouldn't be able to actually find an inverse. So this just says, hey, it's doable, basically. So when I look at this, I would just start out by writing y equals negative x to the 4th. And my first step is to swap my x and my y. So now I'm saying x is equal to negative y to the 4th. From here, I want to get y by itself. To get y by itself, I'm going to first divide by negative 1. And so when I divide by negative 1 here, I get negative x is equal to y to the 4th. From here, I want this y to the 1st, so I'm going to take the 4th root. And so I'll take the 4th root here as well, and I get y is equal to the 4th root of negative x. And we're good to go. Any questions on this one? Perfect. Oh, no worries. Happens to the best of us. Break it up here for 25. To verify that two functions are inverse functions, we would take one and plug it into the other, and take the other and plug it into the first. So when I'm doing this, I'll say the f of x thing is in blue. We'll say the g of x thing is in purple. I will want to show that f of g of x equals x. That's my goal. And I also want to show that g of f of x is equal to x. So that's the goal that I'm trying to do. If I'm able to do that, then they are inverses of each other. If I can't, then they're not. So let's do f of g of x first. So this is going to look like negative 2 times this thing raised to the 5th, where this thing is the 5th root of negative x over 2. So when I'm looking at this thing and I'm evaluating, I'm trying to solve for it, I say, okay, well, I have a 5th root raised to the 5th, so that cancels off. So I'm just left with negative 2 times negative x over 2. I do some multiplication here. The negatives cancel off. The 2's cancel off. I'm just left with x. So we're good to go on half of this thing. Now we just want to do the other half. So now I'm going to be plugging in, try and separate it here. So I'm plugging in f of x into g of x. So now I'm going to be doing the 5th root of negative x over 2, where my x thing is now f of x. So this is going to be negative 2 x raised to the 5th. And now from here, I want to go ahead and do my distribution. So here I've got negative and negative canceling off, so that's a positive. I have 2 on top, 2 on bottom, so that cancels off. And so now I have the 5th root of x to the 5th, which just equals x. And we have our second verified equation here. So now that I've got it on the left and the right for f of g of x and g of f of x, they're both equal to x, I'm good to go. Any questions on this one? Perfect. That was it for chapter 7 stuff.